So let's talk a little bit more about confidence statements. You first learned about that in Chapter 3. We'll come back to that actually later on in the semester. We have a whole chapter all about this specific content. But I want you to have a good sense of how you would write a confidence statement, what a confidence statement looks like, and how you would interpret a confidence statement. So in our previous example about the fruits and vegetables, remember that we had a situation where we were told that 6% in the sample knew about the recommendations for fruits and vegetables. And we figured out the margin of error. We did a quick estimate of the margin of error, and that came out to be 2%. So how can we use that sample statistic and the margin of error? So remember that what we want to do is we want to take the sample statistic. Let me write that over here. We want to take our sample statistic and we add and subtract the margin of error to help us create our confidence statement. So again, we take what I just said. We take the sample statistic, add and subtract the margin of error, and we end up then getting two values. And then we plug those values into a sentence. We are 95% confident in this case, again, that between 4% and 8% of the population of all adults are aware of the recommendations, the daily recommendations for fruit and vegetable consumption. So we always conclude our statement by putting it in the context of the original problem. And again, we always want to remember that when we make confidence statements, we're making them about an unknown population parameter. We're trying to estimate an unknown population parameter. So you want to make sure that you state your confidence in terms of what you believe is going on in the population. So a few more things related to responding and bias. So bias is definitely a big thing that you've learned about in the past several weeks. Let's imagine for a moment that I poll all of you in the whole class and I ask you an embarrassing yes or no question. Now also let's imagine that in the population that the percentage who would actually answer yes to that question, so if we could survey the entire population, the percentage who would actually respond yes is 70%. So that's our true parameter. That's something about the population. Now, one problem we would run into if I were surveying you is we could have response error. So think about why we would have response error. So we would have response error because if it's an embarrassing question, you might not really want to say yes to that question. You might want to say no. So you're not responding in a truthful way. The other problem is bias. So again, if you're not telling the truth, then we're going to underestimate what's actually going on in the population. I might think that a lot of people in the population would normally answer no, when in reality they would actually say yes. So we have to always be thinking about that when we take our samples. Are the individuals responding accurately? Are they lying? Are they misinterpreting the questions? Are they just not remembering correctly because it's been a long time since something happened? You're asking them about something that maybe happened several days ago or weeks ago or years ago. So we have to think about how that could affect what we're trying to determine about the population. And again, bias would be we're systematically overestimating or underestimating what's actually going on in the population. So let's shift gears here. Let's talk about a study that was done. This is based on a headline that grabbed my attention a while ago. Of course I behaved like a jerk. I was just watching Jersey Shore. So some of you might remember the reality program Jersey Shore. So in this study, 127 college students were subjects or participants. The students were randomly assigned, so this is important, to one of three groups. So one group watched a reality show featuring little or no aggression. Another watched a reality show featuring a lot of interpersonal aggression. And the third group watched a violent fictional crime drama. So think about this study. After watching the show, whatever show they were assigned to watch, The participants took part in a competitive reaction time task where their level of aggression toward a fictional opponent was measured. And the results showed that those who watched the reality shows with the most interpersonal aggression were the most aggressive in this computer game. So hopefully you get kind of a good sense of what the study was about, what was manipulated here, what was measured, what the response was. So again, we could throw a question like this at you and ask you to tell us a few things about this scenario. So this was an experiment. What was the explanatory variable? So what was being manipulated? The type of program. What was the response? I'm just going to call this aggressive behavior. So is that the best way to say this? So of course I need to spell aggressive correctly. So we were measuring aggressive behavior. Why was it important to randomly assign subjects to groups? Why do you think that? So think about what happens when we randomly assign to groups. This is a way of controlling lurking variables. So the nice thing about random assignment is that if we randomly assign individuals to groups, we hope that at the start of our study, our groups are equivalent in terms of all those other possible variables that could affect the response. So we're trying to start our study with equivalent groups so that once we apply the treatment, we can be more confident that it was the treatment that was leading to the response, since that's the one thing, hopefully, that will be different across the groups, and not all these other things that we were not able to control. So that's one of the reasons that we want to randomly assign. We want to be able to draw cause and effect conclusions, and we know random assignment can help us do that. What do we mean by control in an experiment? So, I'm trying to think of a good way to say this. What do we mean by control? Keeping things constant. That might be a way to think about what control is. So when we control in an experiment, we're trying to make sure that we take into account, so another way of thinking about this is taking into account other possible variables that could affect the response and trying to build that into our study, trying to make sure that we are keeping those variables constant across our different groups so that, again, when we look at the results, we can be more confident that it was the treatment that was leading to the results and not a particular variable that was not controlled for, that was not kept constant or taken into account. So suppose that in the Jersey Shore study you learned that while most subjects were only allowed to watch 1 hour of programming, those assigned to watch the reality show with interpersonal aggression were allowed to watch 2 hours of programming. So why is this an example of confounding? So amount of programming gets mixed up with type of programming. So you might remember that confounding occurs when there's another variable that we don't control for that affects our response, and it gets mixed up with our explanatory variable in such a way that we can't be certain what is actually affecting the response. So it could be in this particular example that it was the type of program that's affecting the response, or it could be that just watching more of something is going to lead you to be more aggressive. Or maybe it's a combination of the two. We don't really know because we didn't control for the amount of programming. So something is confounded, a lurking variable is confounded if it relates to the response and it gets mixed up with our explanatory variable so that we can't determine what's actually impacting the response. So let's shift gears now and talk about graphs. How would we interpret a histogram? So we spent some time talking about histograms. So look carefully below at this histogram. This shows the number of 8-ounce glasses of water consumed by residents of a local nursing home on a typical day. So how should the axes be labeled? So hopefully you're remembering that along the x-axis, we have what we're measuring. So here we're measuring the number of glasses of water consumed on a typical day. And then the y-axis would be count, or frequency, we could call it. Or we could say number of residents. So we're looking at how many individuals are falling within different intervals along the x-axis here. That's what the y-axis is telling us. So typically we'll call it a count or a frequency. What is the shape of the distribution? So hopefully you're remembering that here our long tail is pointing off to the right. So as I'm looking at this histogram, it's pointing off to my right. The direction of the tail is what tells us something about skewness. So this is skewed to the right. And again, the reason is because that long tail is pulled off to the right. Okay, so quickly let's go through one more slide. We might ask you something like this. So look at this histogram here. Approximately how many nursing home residents were in this study? How could you figure that out? So remember, the heights of these different bars tell you how many individuals fall within these different intervals along the x-axis. So one thing you could quickly do is just look at all the heights and then add them all together, and that would tell you how many total people you have. So here I know I have 3, I could see that here. I have 4, 4, here I have 7. Again, I'm looking at the y-axis here. Here I have 8. So we could do that for all of these different bars, and if you do that and then add everything together, you'll end up getting 44. So we do have enough information to figure that out, and I am including the outlier. You might be tempted to exclude it, but there's really nothing that tells us we should be excluding it. There's nothing we really know about the study that might lead us to think that that was an error. It could be, but all the information we have now suggests it's a legitimate value. So unless we know otherwise, we can't just throw it out of our study. Okay, I will pause here and we'll come back for some more.